In our last video, we have seen how to pass the arguments to the Linux kernel driver. In this video, we will explain you the major numbers, minor numbers and how to create them. Hello everybody, welcome back to Embetronics. This is SLR from Embetronics. Please smash the like button and subscribe button and press the bell icon if you want to get notified whenever we post a new technology video. Let's get started. First, we will see the concept. Assume that this is the hardware. This is the Linux device. The Linux device driver will be at the bottom level. This driver creates a device file. My diagram would be very bad. Please excuse me. We will see this device file in our next video. This is the application area and this will be a kernel space. When the application wants to talk to the hardware, it will open the device file and writes or reads it. Then the device file finds a corresponding driver and communicates with it. Finally, the driver talks to the real hardware. This is how it goes. Here, when the application is opening the device file, there will be many drivers in the Linux system. Driver 1, driver 2 like that. How the device file finds a corresponding driver? Any idea? The kernel will assign some numbers to each driver. That number is nothing but major number and minor number. The driver has to bind the major and minor number to the device file. So, when the user space app opens the device file, it will find the corresponding driver using the major and minor number. Traditionally, the major number identifies the driver associates with the device. A major number can also be shared with the multiple device drivers. When you check the proc devices, you will get the major numbers. Here, major number 1 is assigned to mem driver, 4 to VC0 and again 4 to TTY. For the block devices, these are the major numbers. Minor number. The major number is to identify the corresponding driver. Many devices may use the same major number, so we need to assign the number to each device which is using the same major number. So, this is a minor number. How do we allocate the major and minor number? There are two ways. We can allocate statically or dynamically. Let's see the static allocation first. You can take any number and ask the kernel to assign that particular number to your driver. This is called static allocation. Using this register chardev region function, you can ask your major number. The first is the starting device number that you are requesting. Count is the contiguous device numbers. The name that will be available in the proc devices. This function will be returning 0 if it is successful. If the requested number is not available, it returns non-zero. The first argument of that function is dev-t, which is the combination of major and minor numbers. We can use this mkdev macro to generate the dev_t. We have to give the major number and minor number. Using this major minor macro, we can separate the major number and minor number from dev_t. Basically, the dev_t has a 32-bit value, where the 12 bits are allocated for the major number and 20 bits are allocated for the minor number. See this example now. I am requesting a major number as 235 and minor number as 0. This mkdev returns dev_t format. Then the dev_t is passed to the register chardev region function as a first argument. I want only one number, so the second argument is 1. The name is Embetronics dev. Here, the kernel tries to assign the major number to 35. It will return 0 if it is assigned. Let's go through the code. I am creating the dev-t using the mkdev macro. There, I am giving 235 as a major number and 0 as a minor number. In the init function, I am just requesting the kernel to allocate my asked major number and minor number. In the exit function, I am unregistering the major number and minor number. I am using this makefile to build my code. Build the source code in both Ubuntu and Raspberry Pi. Load the module now. Check the D message. See here, the major number is 235 and the minor number is 0. In Raspberry Pi also, it got assigned. Now, we will read the proc devices. Embetronics dev's major number is 235. Same output in Raspberry Pi as well. Finally, unload the module and clear the D message. Now, we will move to the dynamic allocation. If we don't want the fixed major number, we can let the kernel to assign the available major number and minor number using this alloc chardev region. In the static method, we have to pass the dev_t, but here we will just pass the pointer and the kernel will fill the pointer with the assigned value. The other three arguments are the same as the static method. This function returns 0 on success. In this code, we are allocating the major number and minor number dynamically. Alloc chardev region is called in the init function and we are passing the address of the dev_t as a first argument. Then, starting minor number is 0, the count is 1 and the name is Embetronics dev. In the exit function, we are unregistering the major number and minor number. We have to unregister this major number and minor number once we have done. This unregister function is the same for both static and dynamic methods. Using this makefile, we can build the source code. We did not ask any particular major number in this example, so the kernel will allocate any available number. First, build the source code. Load the module. Check the D message. In Ubuntu, the kernel is assigned 237 to our module's major number. Check it in Raspberry Pi. Raspberry Pi has given 235 to our module. Now, read the proc devices. In Ubuntu, 237 for Embetronics dev and 235 for Raspberry Pi. In Raspberry Pi, 237 is not available, that's why it has given 235. Unload the module now. Now, what is the difference between static method and dynamic method? A static method is really useful if you know the major number that you want to start in advance. So, it will assign you that number based on the availability. But in the dynamic method, we will just let the kernel to give any number to us. To avoid the conflict, the dynamic method is preferable. The disadvantage of dynamic assignment is that you can't create the device nodes in advance because the major number assigned to your module will vary. In this description, I have provided the link of the example source code and web version of this video. In our next video, we will see how to create a device file. Please make sure to subscribe to us. Thank you.